just going to clone this fresh. So if you wanted to follow along, you can do this as well. So again, I'm on Bitbucket under the Bootstrapping Microservices organization under example 2. You come to the main page here and you can click clone. That'll allow you to copy the command. You need to clone this. So that's a git command. It's going to clone this locally. Obviously, I've already got a copy of example 2. In fact, I've got 2 copies of example 2 locally. So I'm going to make a third one and I'll just call it working. Okay. So I'm going to clone that locally. This shouldn't take too long and it's done. That's awesome. So go down into working. I'm going to open Visual Studio Code on this directory. So what we've got here basically, open in Visual Studio Code, is a fairly basic, fairly typical Node.js microservice. This can be any code. This could be Java. It could be Python. So please just pretend that I'm working with your favorite programming language, because this is about Docker and Terraform. It's not about which programming language you use to do microservices. We got the basic Node.js stuff you need here, like package.json, which contains the dependencies and metadata about the project. We've got 2 Docker files. We're going to look at those in a moment, a dev version and a prod version. I'll explain why we need 2 in a moment. If you're just getting started, you can get away probably with just 1 Docker file. But I have different needs for development and different needs for production, and that's why I have 2 separate ones. We've got a configuration file here. That's a YAML file. It's a configuration file for Bitbucket pipeline. So that's where we configure a continuous delivery pipeline. Under source, we have the source code for the microservice. It's just a simple, let's have a quick look at that. That's what we were looking at before, basically, where we changed hello world to hello computer, which you'll see just here. So it's just a small, simple, really trivial microservice implemented in Node using JavaScript. Under the scripts directory here, we have various Terraform files and a couple of shell scripts to help us as well. So we're going to come back and we're going to have a look at the code that's in those in a moment. But first, I'm going to show you how we build this. So I've got Docker Desktop for Windows installed, but it's actually using the WSL2 Linux, what do you call it? Like sort of backend for Windows. Like it allows you to get basically any kind of Linux flavor really running directly under Windows. So Docker uses that. So it's not. I'm not running Windows containers. I'm actually running Linux containers, but in an Ubuntu WSL2 VM under Windows. If you like working in Windows, it's a great way to work. It might sound complicated, but you can trust me, it's fairly easy to set up. I've deleted all my local images. So when I do Docker image ls, normally I'd have a big list of images here that I had cached locally or that I've been building locally. Before this session, I've deleted all those just so we can keep it simple and you can see what I'm doing. And now I want to do the Docker build command. I'm going to tag it. I just have to, just off to the side here, I've got a cheat sheet where I've got all important URLs and stuff like that. So I'm just going to have a look in here and see if I can find the address of my Docker registry. Oh, there we go. So I'm just tagging this with the registry that I want to push to. And what else do I need here? I need to give it a name. So the pod that I already had running, which is the same pod as I'm about to deploy, and I don't want them to conflict. So I'm calling this pod, instead of video streaming, I'm just going to call it video. I should really call it video dev or something, but it doesn't matter. This isn't production. This is just a simple example that I'm going to delete after this session anyway. And now I need to tell it which file to use. So normally you don't have to do this. It will just default to a Docker file, but I want to tell it to use my Docker file prod. So I'm using the prod version of the Docker file. I'm telling this dot at the end tells it to work with the current directory. So this is going to take a moment because what it's doing now is it's pulling down my base image. I should really update this to a later version of Node, but I'm using Node.js 10. I'm using the Alpine version of that. So Alpine Linux is a cut down version of Linux, which is smaller for production. So really good if you want to reduce the size of your Docker images that you're building. So you can see here that it's, it went pretty quickly there, but it installed production dependencies. We're going to have a look in the Docker file in a moment to see how this all works. It's copied source code in. We're hard coding some videos. You see here it's copying the videos. We're hard coding them into our Docker image. Now, if you're making the next Netflix, obviously you don't want to hard code videos into an image like this. They're going to be stored in some database somewhere. But just for this simple example, we're basically baking one video into our Docker image, and that's the video that we're playing when you hit the video route on the web page. You see here the command for actually starting the microservice, npm start. That's the conventional command basically for starting a Node.js application. If I do a Docker image ls now, you can see that I've got the Node base image. That's the version 10 of Node. And I've got this specially tagged image here. You've got the unique ID for the image here, which you can use to kind of do things with that as well. Now, I want to publish this image somewhere where I can get to it in the cloud so I can deploy it in my Kubernetes cluster. The first thing I've got to do, though, is I've got to log into my Docker registry. So I'm going to use the Docker login command. Again, I've got to just find the URL for my registry. Now, if you're thinking this is a bit of a pain, having to type all this stuff in at the command line, yep, that's why we automate this. And I'll show you how this is automated after I've showed you the manual process. So now I type in my username, which is IC demo, and I'm just going to give my password away to everyone. No one's going to abuse this, are they? Hopefully not. It doesn't matter anyway. I'm going to wipe out all this after this. After this demo is complete, this will all be gone. So I'm just logging into my container registry. Now I'm going to use the Docker push command to push my local version of this image up to my registry. And we called it version 1. This is version 1 of this new container. Actually, I might have to... This isn't going to work. I think I've actually already got a version 1 up there, right? So I'm just gonna retag it or rebuild it with a new tag. Let's say we're working with version 10. We've jumped ahead in time. We're working with version 10. I'm gonna now. I'll do my Docker push now. Version 10. So this is now being pushed up to my private container registry that I've got running on Azure. You can run container registries anywhere. You could run it on your own machine if you want. You can run it on any cloud vendor. It's I've actually been playing with building these things manually recently, and there's on Docker Hub. If you search for registry, you'll find the official image for the Docker registry. That's by Docker themselves. So you can set this up from scratch pretty easily if you want to. But there's a whole lot you've got to consider, obviously, with security, if that's the case. Before we get to Terraform, let's have a look at the Docker files that we just used. So this is the prod Docker file. The first line here shows you the image that this is based on. So it's based on Node.js 10 using Alpine Linux to cut down the image size. Then we set a working directory to work within for the build process within the Docker image. We're copying across the package file and the package lock file. That's what we need to install dependencies. And then we're installing dependencies. So this is installing using npm, the Node package manager, to install dependencies. This bit here, only production, is basically saying we only want the production dependencies. We don't want any of the development dependencies. So that cuts down what we're going to install. Having a more minimal footprint for our images for production is good. Then we're copying across all the JavaScript source code. I mean, there's only one file. There's only one JavaScript file there, but if you had more, that would also be copied across. Then we're copying across the videos. If we have a quick look over here in the videos directory, you can see that's where my sample video is, an MP4. It's just a really small video, so just good for testing. And then the command here is basically what we run to start this application within the container. And we can see where this start script is implemented if we go to package.json. So we're just looking at package.json now. You can see that there's a start command here. So when we run npm start, it actually runs this little snippet of command here. So it's saying to run Node with the main source file for this microservice. Now there's also start dev. So that's where I use nodemon. It's similar to the previous command, except we're using nodemon instead of node. And what that's doing is it's going to restart the microservice whenever the code changes. that's really important. That's live reload. It's like hot reload for within your container. So when I started development version of this, which I don't talk about, I don't have time to talk about that really today. You can find out how to do that in my book, Bootstrapping Microservices. But when I run a complete microservices application on my local computer, I'm doing that using Docker Compose, and I've got it set up for live reload across the entire application. So for each microservice, I'm using Nodemon. And then the difference with the dev Docker file is that we don't copy the code across. Nowhere here do you see the code being copied across. And in fact, we don't even bake the dependencies into the image. So what we're doing here in the start command for the container, we're setting up the Node.js cache or the npm cache for caching dependencies. And we're doing the install at startup time. And the reason for that is because the way this is working, we'll be able to kind of, using shared volumes, we'll be able to share the npm cache with the host operating system. So we're persisting the cache. So every time we build a new image and we start a new container off it, we're going to reuse the same downloaded dependency. So that makes startup of a container a lot quicker. And it makes building the container a lot quicker as well, because installing dependencies in an image while you're building it is one of the slowest parts of this. And then, of course, we run the application, the microservice, with this start dev command. So that's what enables Nodemon. Now, the thing we're missing here that I'm not showing today is the Docker Compose file that sets up the sharing of the volumes. So that's in my book, though. So if you're interested in how to get a real efficient development process working live reload for your whole microservices application, please have a look at my book. You can read the first chapter free if you go to the webpage. I'll show you that at the end of this. So that's the Docker file that we just built. Sorry, the prod version. We'll go back to that. This is the Docker file that we just built. We built an image from that. We looked at it using Docker image ls. Let's see that again. So that shows your local images. You can see we've got the previous version 1 that I tagged, and also the version 10. But I think I'd already kind of published version 1 in my test earlier, so I didn't want to cause any problems. Basically overriding that, and then we pushed this image. We pushed the version 10 of our image up to our Docker registry. So it's there. Our Docker image is there. It's waiting to be deployed to Kubernetes. We're just going to use Terraform to do that. Now, obviously, you could use kube control. Something like create deployment -- image, and then you type in the name of your registry, the name of your image, and any other commands, any other options you want to apply to that. So we can use kube control directly to manually create this. I'm not doing that. I'm using Terraform to do it. The reason I use Terraform to do it is because then it's like, instead of just being, like a shell script with, running kube control in a continuous delivery pipeline, we've got a proper language there for configuration. And it's really smart. Terraform is really smart as well. It knows the current state of your system, and it knows the changes that you want to make to get it there. And kube control just isn't that smart. Even though we're using kube control under the hood, we're using Terraform, but under the hood we'll be using kube control. So let's have a look where we are with the Terraform code. Close these files. So just under the scripts directory of this repo here, all the Terraform files, and then just some helper shell scripts that I'll show you in a minute that help us kind of put all this together. This whole thing is designed to run on a continuous delivery pipeline. So it's got some backend set up here, which is what configures the state, the storage, like the backend storage for the state of the continuous delivery pipeline. I don't need this running locally. In fact, it's going to cause problems because it might confuse it might use that persistent state of my live continuous delivery platform as my local state. I don't want that. I just want it to have completely local state. So I'm commenting out the code that's in backend.tf here. Now, to use Terraform, I've got to be in the same directory as the Terraform scripts. So I'm going to cd down to the scripts directory. Have a look there. That's where all our Terraform scripts are, and the shell scripts as well. I'm just going to check what version of Terraform I'm using, because the thing is, I'm using, for this demo, I'm using an old version of Terraform. I'm using version 0.12. But for my production work at the moment, I'm using 0.14. But I haven't upgraded my demos to that yet. So I'm just going to stick, for this demo, I'm just sticking with version 0.12. And whenever you clone a fresh Terraform project and you want to run it locally, you've got to run Terraform init. If I can spell it right. There we go. That's better. So this is downloading all the plugin providers that I need to use, like the Kubernetes provider. I don't know if I need these. No. So the reason that Terraform can work with any different type of cloud provider and also work with Kubernetes is because it's all driven by plugins. So there's plugins for any kind of thing you want to connect to and any kind of thing you want to configure. At least all the main ones anyway. So we have initialized now. What that means is that we'll have a low. Let's do an ls minus -l so you can see everything. Oh, you can't see the hidden files. That's all right. But if we do an ls in the Terraform directory, so it creates a hidden directory called .terraform, and in there is where it downloads all the stuff that it needs. Now, if I run Terraform apply, it's going to automatically. Let's just show you. So it's gonna look at all the TF files here, and it's going to execute the code in these Terraform files, right? But I've got some inputs. I've got some variables I need to provide it, like this one here. I need to tell it where to find my Docker registry. Now I could enter that all here, like let me show you. I'm just copying and pasting my registry name in. That's all good. But the problem is when I get to this point where it asks for the certificates, like the keys that I need to authenticate with my Kubernetes cluster, if I try to copy them to the command line, something goes wrong. It corrupts the key or something like that. It doesn't seem to work. So I'm going to create a little batch file to do this. Now again, I'm only demonstrating how to do this manually. So the ultimate aim is to do this all automatically. And so you won't be sitting here typing stuff at the command line. You won't have to be creating these kind of batch files and stuff like that. But let's just go back to code, Visual Studio Code here. I'm just going to create a new file called deploy local.bat. This is a batch file because I'm just running it directly under Windows here, so I can't run a shell script unless I open a Ubuntu terminal. So I do have Ubuntu running as a virtual machine on Windows 10, but I'm just going to keep things simple. So we want to run Terraform apply. I'm going to set it up to auto approve. Otherwise, you have to type yes, and that takes a lot of time, doesn't it? So we want to speed this up. So we're going to auto approve the changes we're going to make. I'm just using the line continuation character here. So we're spreading one command out over multiple lines. Now I'm passing in variables directly. So this is sort of how we get this running on continuous delivery as well, is that we've got to wire in all the variables that we want to pass in. So the first one, in fact, let me look at my variables file. So this TF file here is just all the variables that I need. Not that one, that's the wrong one. So these are all the variables I need to supply. So I can kind of just copy and paste these across to get this running. So my Docker registry, let me just grab the name of that again. So that's the first variable that I need. The next variable I need, what's the variables that we need? So the next variable I'll have is the service name. So we're calling this sort of test version video instead of video streaming. The next variable I need is the version. So that is going to be version 10. So that's the version that we published that we want to get on our Kubernetes cluster. Now I have to give it the authentication details. Now I have to give it the connection details it needs to connect to my Kubernetes cluster. So I'm just going up to my cheat sheet to just get some of these details because they're quite big and you're not going to want to watch me type these in. So this is the Kubernetes host that we're connecting to. Now comes the interesting bit. I need some of these certificates and connection keys and And these are the big ones. These are the ones that if I cut and paste these directly to the command line, somehow it corrupts them. I'm not really sure why. By the way, all these details that I'm typing in for connection with the Kubernetes cluster, if you watch the first version of this video, you'll see how I got these. You'll see how I built my cluster and how that process of building it, the output of that was all these keys that I needed to connect to that cluster. Now, hopefully this is all good and I have not typed anything wrong. I've just got one more, this CA certificate. I think that's all I need. So now I can run this batch. Oh, I need a line continuation there. Do I need one there? Yep. Do I need one there? Oh, I've got one there, cool. So that's all good. Let's just close down this variables file so you can see this whole thing. So this is the command, Terraform apply, auto approving it, otherwise we'd have to type yes at the command line. And we're passing in a whole bunch of variables to use within the Terraform code, the things that it needs to be able to connect to our infrastructure and deploy stuff for us. So I'm just going to run this. Fingers crossed. Oh, before I do that, I'll just show you the pods that we've got running already. So these are the containers that are already running on my Kubernetes cluster. There is just this single video streaming one. But after I've deployed the new one, I should see one here that's not video streaming, it's just video. It's going to do the same thing. I'm just doing a demonstration to show you that I can do this. Oh, I don't want that. I want the deploy script. So I'm running the deploy batch file that I just created. Oh, sorry, deploy local. Have I missed a line continuation character here? That's really weird. I don't know what's wrong with that, but I'm just going to get rid of these line continuation characters, just put it all on one line. Hopefully that will avoid me having to figure out what's actually wrong with it. Okay, let's try that. Run it again. Fingers crossed. Praying to the demo gods. Oh, it's looking good. It's creating something. Now, hopefully this isn't going to take too long. While that's going through, actually, let's have a look at the Terraform code that makes this possible. So, you've seen the variables file. You know, that's where a bunch of variables are set up. You could put defaults in here. Like you could say default equals, you know, some default of this variable. But the fact that we haven't got defaults there is why you have to provide them. Why you have to provide them at the command line. And so you're forced to provide that configuration. The provider's Terraform file is basically just where we set up Kubernetes. So this is where we're using some of those variables. So the keys here, we're plugging these into our like our connection details for our Kubernetes cluster. We've got this is the important one. So this is the Terraform code that actually deploys our microservice. There's two parts to this. There's the Kubernetes deployment and the Kubernetes service. A Kubernetes deployment is something that basically manages a replica set for us and a bunch of pods. Now we're only kind of instancing one pod here, but you could instance as many as you want. And this deployment is basically responsible for keeping them alive. If any of them die, it's gonna boot them back up again. So we start with a bunch of metadata here. Here is the spec for the pod. This is the number of replicas. So we only have one of these things running. We could easily change it to 3 or 30, however many you want. If you want like a load balanced microservice that has many workers, really easy to kind of scale up using Terraform and Kubernetes. And here we've got the template for the container. Down here is where we're plugging in the image. So again, here we're making use of variables. We're composing the image name of the Docker registry, the service name, and the service version. So that's using Terraform interpolation to basically build that string and get that thing for us. And it kind of means we can, if we wanted to, we could reuse this Terraform file for other microservices, and we just plug in the name. We just plug in the name of the thing that we're deploying. So it's a fairly common configuration. There's an example of an environment variable configured here, which tells the microservice which port it's going to use. And we can configure other environment variables here, other environment variables that, that we might need to plug into our microservice. Now, if you want to access this first part, this Kubernetes deployment, that deploys our containers into the Kubernetes cluster. If you want to have them accessible via DNS, you have to put a Kubernetes service on it. So that's what makes it exposed internally. But what we're doing here is at the end, this last bit is important because adding a type load balancer is what provisions a load balancer, an external load balancer in the cloud vendor so that we can get external access. So if this was going to be an internal microservice only and you didn't want to access this from the outside world, you just delete that and you have it like that, and it's just an internal private microservice, which can be good for security. Most of your microservices in your application are probably going to be internal only, and only because we want to get to this from the outside world so I can show you that it's working, do we put the load balancer on there. But you know, if this was your web server, if it was your gateway microservice, something like that, you also want to do this. You also want to do this so you can expose it. Okay, let's have a look. Cool, that's gone through. If I do kube control get pods now, we should see our video pod here. We can also do, if you want to see the actual deployment that's looking after that pod, you can do kube control get deployments. So that shows you there's a deployment after that as well. Now let's look at the external IP address for this. If I do a get services, you can see we've got two external IPs. This one here is the external IP for our latest one. So we can have a look at that. It should give us hello computer. Great. We should have a video route. Great. We've just manually deployed a microservice.